I was thirsty, so I decided to use a Coors Banquet can instead of a soccer ball because I did some research and turns out you can't drink soccer balls, and I was thirsty at the time. Now, you'll notice that I have my calibration stick in the center of the screen. And that's because, being that I use a cylinder, that was the kind of the easiest spot for me to show that it was about 6 centimeters wide when it was, closest to being a perfect circle. I also didn't know the mass of a beer can off the top of my head, so I decided to use the mass of a soda can, which turned out to be 370 grams. So let's go ahead and watch this video now. And as you see in my blurry vertical screened video, that the can is slowly moving across that table. In any case, so that's the video showing it moving along the negative x-axis. If I were to choose, I could have flipped the axis and be moving in the positive x direction, but it didn't seem like it was necessary. And so here's my program. Here's my ball's mass, 370 grams. And then here is my initial velocity, which was just between the first two frames, the final position and the initial position of the can over the final time and the initial time, which came up with negative 0.735 in the x direction 0, 0. So now that we know that, let's go ahead and run this bad Larry. Yeah, there that goes. Come on, you need to run. Oh, yep, slowly. And there it goes. Alright, as you can see, it's fairly similar to what happened, other than that giant ball representing my Coors can. Here's the graph, kind of what you expected with a constant velocity, just a straight line. So I took my information from this graph and which is what you would anticipate, and my recorded observations, and I made a little graph about it. Sorry that it's so tiny. So here's what the program thought would happen based off of a constant momentum, being that no other net forces were acting on the can, like no gravity, no drag, no friction, nothing like that, just a constant solid push on the table. Here's what actually was happening. You can see at the end of the table it started to slow down, which obviously was because of gravity and the friction of the table. Also, the table realistically was a little lopsided, so the can would have slowed down no matter what. So it's good that the model looks fairly similar to what I observed, but you can definitely tell that there's a difference between not having any net forces acting on the can and obviously having some forces acting on the can. Yeah, so that would be showing the momentum principle, being that there would be no net force for the Newton's second law equation, so it would just be a constant straight line, as shown by that graph. Okay.
Oh, thanks.